Welcome, everyone. Good evening. Thank you for joining the Philadelphia chapter of Informed Speaker series. This is our fourth session that we've had in the last fiscal year, I suppose, or maybe calendar year. And I hope everyone is doing well. Now that we're getting into the summer, likely also going back to the office. Many things going on, hopefully all positive. Today we have Robert Cheatham from Acevia. He's CEO of Acevia. Acevia is a technology and a geospatial technology and research company based here in Philadelphia. And they focus on the application of geospatial data analytics for civic and public good. And today, Robert is going to talk about applying satellite data for public good and some of the interesting applications that are kind of like the current state. We have a Q&A box. Please, we're going to wait until the end of the presentation to handle some of the questions that you may submit. So post them there. And when Robert is done with the presentation, we're going to select some of those questions, hopefully all of them, and we can handle them one by one. And then at the end, we'll make an announcement on what comes next after this session. But with that, I leave it to Robert to start that off.
All right, I think I'm sharing. Everything good, Ariel? Okay. Thank you for the kind introduction. As Ariel said, I'm Robert Cheatham. I'm the founder and CEO of Acevia. Acevia is a software firm based in the Philadelphia region. This is us. We're a group of folks applying geospatial technology for good. About 20 years, just celebrating our 20th anniversary right now, about 50 people, most of which are in Philadelphia, but some are distributed around the United States, and a couple people even working internationally. About half of Acevia's work is in the public sector with local and federal government, and another half is a mix of nonprofit, philanthropy, and private sector. And while we began as a very much Philadelphia-focused company, where these days most of our work is national and international. We are a mission-driven company. So we are what's known as a certified B Corporation. I don't know if everyone's familiar with B Corporations, but the idea actually began in the Philadelphia region, and today there are about 3,000 B Corporations. But B Corporations are organizations that operate with a social mission. They're all for-profit companies, but operate with a social mission. Some of the ones that you may be familiar with that are also B Corporations are places like Etsy and Patagonia and Ben & Jerry's and so on. So our mission is to advance the state of the art in geospatial technology and then apply it for civic, social, and environmental impact. So we create new geospatial tools and then apply them for public good. All of our work has a place or geography component to it. We pick and choose our projects carefully and really only take on efforts that have at least a chance at social impact. We're very design forward firm that focuses on UX design. We generally take on complex problems. There was a time when putting any kind of interactive map on the web was difficult back when Azavia was started, but over time we've worked to focus more on decision support and things that have a significant technical challenge to them. A lot of our work today either relies on or contributes to open knowledge systems. We're big users of open source technology and open data, and we have some of our own projects that are re-released under open source licenses. I'm going to spend most of my time talking about satellite and other kinds of imagery and what's been changing in that world, and some of the tooling that's available and the applications where we're doing work. But Azavia is a much broader firm than just that, so I thought it might be helpful to give you a flavor of a few of the projects we're working on. So I'm going to spend a few minutes to walk through some examples of some of our contemporary work. One area is in the apparel supply chain. This is an effort known as the Open Apparel Registry. As many of you know, apparel is a huge industry and employs a lot of workers around the world. It has enormous social and environmental impacts. Not many of them are negative. Several years ago, some of you may remember a building collapse that was we're all experiencing a building collapse in Miami, but this was one in Bangladesh that killed a lot of people and really highlighted a lot of attention on the plight of workers in the apparel industry and some of the conditions in which they work. Following this, there were a lot of calls for greater transparency, and there were a lot of companies that responded. A lot of the brands that we all know and love, whether it's Nike or Disney or what have you, people involved in the apparel supply chain started releasing some of their data. But these supply chains are complicated. There's lots of, it's not just the company that may buy the goods, but their factories, their subcontractors and input suppliers, all the way back to the raw materials. And while let's say a Nike may release a lot of its data, it's not done in a standard way that would enable it to be combined with lots of other information. So this project, which was funded by a European philanthropy called the Loudest Foundation, and was put together, it's kind of the brainchild of a couple of folks here in the US and the UK that saw an opportunity through better access to transparent data in a unified database as an opportunity to improve things. So the current state of play is, like I said, there might be a lists of locations that different organizations may release. Those factories and the address or location where they're located might be in something like a CSV file. What the Open Apparel Registry does is try to unify data from different sources. So by creating a unique ID. Now, it was something that was not clear to me when we started working on this, was that a given factory location in, let's say, Bangladesh or China or India or the places might actually serve many different brands. And so if you get like a list of brands from Nike and you get another one from Adidas and another one from Reebok, they may all be referring to the same location, but they may not refer to it all the same way. And so there's a need to reconcile disparate lists of facilities and then be able to assign a unique identifier to them, and then be able, from that, be able to figure out which brands use that location. So this has only been up and running for about a year and a half, but we've already got some really great case studies. The way that people in these countries are using the Open Apparel Registry are to enable workers and civil society organizations to be able to lobby brands when workers are mistreated or not fairly treated. in these countries. So there's an example in Cambodia and another in Bangladesh. The goal here is through greater transparency, be able to enable workers and their advocates to lobby for better conditions. Another type of work that we've been doing for some time is work around legislative redistricting. As many of you know, the United States in particular suffers from significant amount of gerrymandering, where essentially elected officials draw districts to benefit themselves, selecting their own, selecting their voters rather than the voters selecting them. So we've been working with a couple of academics and with funding from the Sloan Foundation to develop an ability to for the public to get involved in the redistricting process. So the result of this is a project called District Builder. Is particularly relevant this year because we'll be seeing the census data released in just a few weeks, and from the 2020 census, and we'll set off a mad rush to redraw all of the district lines, which will then have a pretty significant impact on our politics over the next 10 years. So this is an open source, open data application that we're going to be trying to make this available in all 50 states in the US over the next year or so. Transportation infrastructure, this is a data project. Because of the type of group that Informs is, I've tried to draw out operations engineering types of examples. This is a traffic management tool that was developed for the World Bank called Driver. In the developing world, low-income countries, you often have very rapid urbanization and uptake of vehicles and infrastructure that doesn't necessarily keep up, and traffic fatalities and injuries are actually one of the biggest causes of death in many of these countries, really significant. And in the Philippines, which is one of the countries that has a real issue with this, just having good data on where traffic accidents, traffic crashes occur, and to enable the government to intervene is a big challenge. So this is aimed at enabling police officers and other officials who respond to traffic crashes to track data and then be able to generate forecasts for time of day and day of week when and for different locations, be able to use that data to better position officers to respond or to make infrastructure changes to improve the safety of the roads. So this started out in the Philippines, but is now being used in Vietnam, Laos, Saudi Arabia, and several other places. The way I met Ariel was through a project here in Philadelphia called Open Data Philly. Xavier has a collaboration with the city of Philadelphia. We originally developed some a catalog tool for the city to log its open data sets. And so we did this pro bono and continue to maintain it pro bono, but the city uses this to catalog their data. We have about over 350 data sets now, and not just the city, but almost 60 organizations that make data available there in a bunch of different categories. We've done some COVID response work over the past year. This is an open source project called COVID Care Map that attempted to map differences between bed capacity and ICU capacity and where there were hospitalizations and rising COVID cases. So combining model forecasts against infrastructure availability and being able to see where the gaps were. Fortunately, we're no longer in that particular situation, but we have continued doing some work with the World Bank though around COVID response. This is an effort at a global scale to implement some similar kinds of dashboarding tools, in particular to identify countries where they have what they call compound risk. So not just COVID as a risk, but COVID coinciding with risk from other transmissible diseases, from climate factors, from storms and other kinds of risk. And finally, an effort we did with Vanguard Charitable called Navi that helps Vanguard Charitable essentially aggregates a lot of different donor advised funds, and their contributors wanted to be able to respond to COVID by directing their donations more effectively in a geographic way. So this project aims to enable folks who want to direct funds toward COVID response and do so based on incident rates, vulnerability scores, and so on. So it's a little bit of an introduction to Azavia and our work. I want to spend most of my time talking about satellite and a little bit perhaps about aerial imagery, because these data sets, some of the challenges faced with these data sets don't change whether they're up in space or not. But it might be helpful to just talk about a little bit about the origins of satellite imagery, Earth observation imagery. Back in the 50s, and a lot of the early work all the way up into the early 21st century was really driven by defense and intelligence considerations. There have been some civilian Earth observation satellites, but a lot of the money in this world is a lot of the investment has been driven by defense and intelligence concerns. The earliest United States Earth observation tools were launched by the CIA, and they were pretty radical. They launched with actual film canisters on the satellite, and rather than deorbiting the satellite to collect the film, because they didn't have digital transmission systems, they would actually pitch the film canister packages down toward the Earth, and they'd have these planes with this big catcher hanging out the back, and they would literally catch the film canisters out of the air. Pretty crazy. So this started out as, it's called the Corona program, and a number of satellites went up under this, and these are some of our earliest examples. And in fact, the CIA later declassified all of this, and you can now find all of the Corona imagery. It's available for free and is in the public domain. But this kind of satellite imagery, Earth observation imagery, I'll use terms like Earth observation, remote sensing, and satellite imagery kind of interchangeably, but I'm focused on imagery or sensing about the Earth. It's really been the province of large nation states. It's been a complex, expensive, often took decades of design and construction, and it's high risk. If you have a rocket blow up, you're potentially losing hundreds of millions of dollars of investment in many years. So the U.S. was a leader in this area. Obviously, the Soviet Union and sorry about that, my headset went off. More recently, China and the European Union and others have gotten into this game as well. Outside the defense and intelligence sector, Landsat has been a standout example. This is a whole series of Earth observation satellites that were launched by NASA and operated by the U.S. Geological Survey for viewing land in the U.S. Or actually globally. And then the European Union has had a series of Sentinel satellites. These are big, complex, often multi-billion-dollar endeavors. Here's some example. The Sentinel actually isn't one satellite, it's several of them, similar to Landsat. We then had a period of commercialization in the 1990s and early 2000s, in which we saw similar, very large, launching a bus up into space, size satellites that would take years to build and hundreds of millions of dollars. Here's a few examples from a company called Maxar that has, I think they've got 8 or 9 of these up there, or have had over time. However, we've gone through over the last 8 or 9 years a real transformation, and this is being driven by a bunch of different factors. We've got falling launch costs. Most of you are familiar with probably SpaceX and its ability to take its land its boosters back on the ground. Blue Origin and other companies are attempting to pull off the same thing. This has a pretty huge impact on the cost of launching. If you can reuse your boosters several times over and land them back and turn them back around, it really brings launch costs down. And been other innovations that SpaceX and similar organizations have had over the last few years to bring launch costs down. But perhaps one of the bigger things is miniaturization. All of us probably have smartphones that we all use every day, and these are just incredible wonders of miniaturization. And as they became possible, a lot of the electronics manufacturing and chip manufacturing systems that made them possible have been turned to the task of miniaturizing satellites as well. So this is one of Maxar's satellites, WorldView 3. It was launched in August 2014. It rides up there at about 400 miles above the Earth. It's over 6,000 pounds. It cost $650 million in 2014 to build. This is a dove from a place called Planet Labs. A dove is only about the size of a bread box. Here's a bunch of them all stacked up on a table, getting ready for launch. This is really a product of a mix of the innovation around optics, miniaturization, higher density, higher power output solar cells, and so on. These doves fly in low Earth orbit. They have shorter lifetimes, which you'd think wouldn't be very good, but it also means they're just, because they're cheaper to build and launch, they have lower risk. If you lose one, you're not going to lose your company. Fast release cycles. New versions of doves are iterated every few months rather than every decade or so. So improvements are ongoing, and they're launched in flocks. So dozens at a time, jammed into perhaps the interstitial space on someone's communication satellite, and then are spit out and then put into moved into orbit. I think at this point, Planet Labs has a constellation of about probably almost 200 of these, and there are enough of them that they are able to image the entire planet more than once a day, at least the Earth, the land mass areas of the planet more than once a day. They are largely for visual imagery capture, so red, green, blue bands of the visual spectrum. I think space remains a hard and expensive environment to work in, but all of these things are conspiring to make it less hard and less expensive. Another outcome of this is they are just generating an avalanche of Earth observation data, and this is both a pretty significant opportunity for all of us on Earth as we try to grapple with how to better manage resources on our planet, as well as some pretty significant technical challenges. I mentioned that there are all of this is causing an avalanche of data, but we're really seeing not just more satellites and more data coming off more satellites, but higher resolution, higher revisit rates from these constellations, as well as new resources around different components of the spectrum. As you're all, I'm sure, aware, the visual part of the spectrum that we see with red, green, and blue bands are only a tiny portion of the light spectrum, and we're seeing more satellites that add things like near infrared, as well as multispectral. Now, these aren't major innovations. Landsat and Sentinel satellites, for example, have been multispectral for a few decades, support multiple slices of the spectrum, but there are a lot more of these, and looking at different components of the spectrum. We're also seeing a number of new constellations using a relatively old technology that was developed mid 20th century called synthetic aperture radar. But synthetic aperture radar has advanced, and the innovated to the extent that it can now be launched on relatively small satellites as well. And we're seeing not just one, but several companies launching constellations of SAR satellites. These have the advantage of being able to see through cloud cover. A real limitation of a lot of Earth observation satellites that focus on the visual spectrum is they can't see through clouds. And then more recently, we're starting to see more satellites that are hyperspectral. And what people mean by this, by hyperspectral, is rather than taking several slices of the spectrum that contain information we might want to work with, which is what Landsat and Sentinel does, or just taking a section of the spectrum like radar instruments do, hyperspectral instruments just take a whole big blob of the spectrum, and you treat this as a cube rather than as an image that represents a slice. You're capturing a whole section, and you treat the data as 3 dimensions. And an advantage of this is you can then pick and choose what components of the spectrum that you want to work with, depending on the application that you're interested in. And we've had a couple of small, low-resolution hyperspectral instruments, but NASA's about to launch a large new instrument called Hesperi that will be available to everyone. Then folks like Planet Labs have recently announced that they're going to be launching some climate change-focused carbon mapping and methane mapping focused hyperspectral instruments. And I think there's just an incredible amount of potential that's is still untapped, this sort of thing. So state of the data today is we've still got a lot of these systems are nation state based systems. I've mentioned Landsat and Sentinel a few times. They're very often used because they're open data. They're multispectral, and they have revisits around every 2 weeks or so. So they cycle the Earth and orbit the Earth such that you'll get some repeat imagery every 2 to 4 weeks, and they're in the 10 to 30 meter pixel size on the ground. But it's not just the big nation states like the European Union and the United States, but relatively small countries are launching satellites. Peru now has its own Earth observation satellite that just sits above Peru and images its particular location. The UAE has United Arab Emirates, and as what we think of as a relatively small country, though very wealthy, has launched its own Earth observation satellites. And so the wealthy countries like the EU, Japan, the United States are being joined by a number of others as well. We've still got these large commercial systems. They're often very higher resolution. We're still launching buses up into the air, into space. They're often run by some pretty big companies like Airbus, Maxar, and Spot. They rely on tasking systems, so there's almost no revisit because imagine if you're going to have a camera that's much higher resolution, it's not going to cover as much of the Earth. So you're getting this very small section that you're seeing at very high resolution. So instead of trying to cover the entire Earth over a period of time, they have tasking systems that enable it to be aimed at particular locations, and they sell access to that. And then we have what people sometimes call new space commercial firms. I've mentioned Planet a couple of times. The more medium resolution, 3 to 5 meter pixels daily or more often revisit rates, and they sell that data. Some others to keep an eye on. Capella launched its first SAR satellites last year. Another firm based in Europe called ICEYE also has SAR instruments, and I think they've got about 8 satellites launched so far as their constellation. We've got organizations like Spire that are building commercial weather satellite constellations. A firm called Black Sky that's trying to get high resolution but at lower cost and higher revisit rates. And folks like Hawkeye 360, which aren't looking at, they're trying to detect a section of the spectrum, the radio frequency section of the spectrum, but not necessarily to image the Earth, but to identify sources of radio. So they're doing some really interesting things around trying to um, uh, um, identify illegal fishing, for example. So as some of you may know, when someone um, if you want to illegally fish, you want to do an incursion into someone's exclusive economic zone around their coastal area, they'll often, as many of you probably know, there's a international system for identification of ships called the AIS, and the AIS tracks where a ship is at any given moment and transmits that information. People will turn off their AIS transmitters when they want to do something more nefarious, and comes suddenly very hard to see them. What Hawkeye 360 has been doing with its radio frequency constellations is using the radio signals that are given off just from something as small as a walkie-talkie or other kinds of output from a ship to identify where those ships are, even if they turned off their AIS system. And it's been used in some pretty creative ways. Obviously, this also has applications for intelligence, defense, and other things. All of these this avalanche of new imagery creates lots of problems. Obviously, there's a volume problem. There's a ton of new imagery that's requiring new forms of processing. A need to potentially look at if you've got a revisit rate every day and you want to look at a couple of years of change over time, you've got to be able to look at a temporal stack that may be hundreds of images deep. Got new spectra that we're working with. So we aren't just talking now about two-dimensional arrays of pixels that you might have with any typical raster data set, but cubes of hyperspectral data. And at the end of the day, just not enough humans to even look at all of this and be able to interpret it. So I need to automate examination of imagery in order to pull out just the images that are worth taking a closer look at. I'm going to focus on mostly open source tools here, but some of the things that tooling people are using, we're still using pretty general purpose tools like Gdal. This is a Geospatial Data Abstraction Library. It's a C library that has been around for about 20 years, so it precedes this real explosion of imagery, but it's just incredibly useful and powerful. Very fast and flexible way to move imagery between different formats, projection systems, and so on. In addition to classic raster data structures like TIFF and Geotiff, we're seeing a need to be able to access those types of tools in or segments of imagery in a cloud, public cloud infrastructure environment. So we're seeing new iterations of old formats like Geotiff as cloud optimized Geotiffs. So, or people sometimes call them COGs. But COGs are in the old Geotiff format, which is an iteration of the TIFF format, but are optimized for access of not the entire image, but little bits and pieces of an image that you might want to evaluate, particularly in a machine learning type of environment. Often there's not a single image we're concerned with, but rather whole libraries of images that need to be able to be searched and indexed. So a new standard that's been evolved over the last couple of years is called STAC, or Spatiotemporal Asset Catalog. So there are some new open source tooling for working with stack catalogs. PyStack is one, Franklin is another. And if we've got all of this imagery and we need to be able to process a lot of it simultaneously, tools like GeoTrellis, which is a Scala-based Spark library for doing distributed processing. And the idea behind GeoTrellis is instead of taking two images and combining them to process them in some way, we break the image up into lots of smaller pieces and then parallelize the processing and then bring the results back together. And this is something for which the Apache Spark project is particularly well suited. For automating this type of thing, automating examination and extraction of data. There's a library called Raster Vision. This happens to be something that Azavea has been working on for some time for doing machine learning with geospatial data. Groundwork is a toolkit for doing data labeling, so you can annotate your images and then feed them into a tool like Raster Vision. And then as we have more machine learning work and more annotation, there's a need to potentially share a lot of that. And there's a foundation based in the United States called the Radiant Earth Foundation that's been organizing an ML hub, which is an online repository of machine learning training data sets. That's Raster Vision. I mentioned earlier that a lot of Earth observation got started with defense and intelligence funding. For many decades, defense and intelligence has driven the entire marketplace. And you all are probably familiar with the term monopoly. That's when a single producer owns or controls the whole marketplace and can set pricing and other rules. When I got into this world, I learned a new economics term, monopsony. So a monopsony is a situation in which there's only one buyer and they set all of the rules and control the marketplace. So defense and intelligence has been a monopsony buyer for many decades. If you couldn't sell to defense and intelligence agencies, you basically couldn't operate as a viable business. That's gradually changing. It's still somewhat true. Many of the new companies that I mentioned earlier, Planet and others, also they see defense and intelligence as important applications, but that's gradually breaking down, and we're seeing more and more active ecosystem of buyers and users of data that is gradually resulting in a much greater, healthier marketplace at the end of the day, and much broader array of applications. So here's a couple of examples, people looking at economic activity by counting ships and container ships in harbors. And you can imagine if you can detect just ships, which is actually not a tough machine learning problem, and you can do this simultaneously in a whole bunch of harbors around the whole world, you can get a really good sense of what trade looks like without detailed data about everything that's all of the individual containers they may contain. This is an effort by a US nonprofit called the World Resources Institute called Global Forest Watch. This uses a mix of Landsat, Sentinel, Planet, and other imagery to detect deforestation and afforestation and be able to monitor that on an ongoing basis. It's pretty cool effort. As the resolution improves, we can look not just at fields in agriculture, but individual trees and be able to extract information about them and be able to track that over time. It's another example of looking at economic activity. These are gas and oil tanks, and these are often, as the volume in the oil tanks rises or falls, essentially the dome rises and falls, and so you can measure the shadows on the domes. And if you do this simultaneously across the world, you can get a sense of what oil reserves look like. None of the ones I just mentioned, other than Global Forest Watch, are ones that Azavea has been working on. I just wanted to give you a flavor of some of the things people are doing, but I thought it might be helpful to highlight some of the projects we're specifically engaged in over the past year or so. One of these is with the World Bank. They have a real interest in disaster resilience and climate change, impacts of climate change on global cities, particularly in lower income countries. And the urban forest canopy, this is street trees and parks and so on in urban areas, has a really big impact on water runoff, temperature, air quality, and a range of other things. And so being able to map that faster, and being able to index it in cities is a key interest of theirs. So we've been working with them to both develop machine learning models and approaches to building training data sets that actually integrate people living in these cities, and then being able to use that to map the forest canopy. Second one is around infrastructure management. Part of Azavia's project selection guidelines is that we don't work on projects that are going to expand the carbon economy, but we do have an interest in still working on oil and gas projects where there's existing infrastructure and we can help manage it more effectively or manage it in a way that reduces impacts on communities. So a lot of oil and gas pipelines have to be monitored on a regular basis. The EPA requires this on a particular cadence, and so aerial flyovers are used to detect incursions on the pipelines. So pipelines don't just kind of burst. That's pretty unusual. They tend to, if there's a spill on a pipeline or damage to it, it's usually because there's an incursion on the pipeline right of way. Someone with a backhoe that's doing something that they didn't realize there was a pipeline there. And so being able to detect this is a really key thing, and being able to detect it quickly is important. So we've been working on building machine learning models that can actually be run on the airplane in flight as it's capturing the digital imagery in order to detect construction equipment that's in the pipeline right away. Doing some work here in this region around water infrastructure monitoring as well. This is actually with drones. You all have probably seen water tanks distributed around the countryside and all over the United States. These water tanks are not really used for storing a lot of water so much as they're used for equalizing and managing pressure within water systems. So the tanks are almost all made out of ferrous materials, so they can rust. But they're built at different times in different ways with different construction techniques by different crews. And so they have to be monitored for corrosion. Going and inspecting every one of them every year is pretty challenging. The way this used to be done was a crew would be sent out to each water tank, and they would have to either climb it or get the equipment or have a big crane to sort of send someone around. And you can imagine all the people that would require. This is being done now with drones, though, and so you only need to send one person out with a drone, and they can capture very high resolution imagery of the whole tank. Of course, that generates thousands and thousands of images or video. Combing through all of that to look for the signs of corrosion is pretty tough. So we've been working with a water utility to automate that to detect corrosion, and then be able to use that to score water tanks and prioritize them for painting and other kinds of maintenance that prevents corrosion. Doing some work around disaster mapping and detect after a hurricane or tornado comes through, being able to detect destruction of buildings and infrastructure. Doing some work in one country in Africa around building footprint mapping. A lot of the world, I mean, despite what we may be accustomed to in looking at something like Google Maps, a lot of the world is not mapped, and there aren't building footprint maps, and there aren't high quality road maps for much of the world, particularly in low income countries. And so this makes managing communities a lot more difficult, and simply being able to automate the extraction of roads, buildings, and other things is pretty valuable for the civil and municipal governance of these in these countries. And then lastly, we've been doing some really interesting work around medical imagery. Now, medical imagery you wouldn't think of as geospatial, but it often is captured in conjunction with several images, all of which have overlap and are in conjunction with each other. And the medical imagery world, whether they're looking at clinical trials or capturing imagery from the tests that we may all get, whether that's an endoscopy or a colonoscopy or a breast exam or something like that, managing all of that, the same avalanche of imagery I'm talking about around satellites is happening in the medical field. And so being able to manage that imagery turns out faces many of the same kinds of challenges. So we're working with a clinical trials organization to both apply machine learning and AI, but also some of the data management tools we've been able to build for satellite imagery, but apply it for the medical field. All right, and here's an example of that, what that drone and water tank application looks like. If any of you are interested in getting started with this stuff, I've mentioned a number of open source tools, but the data also is available in a couple of places. Let's see here. The Google Cloud Platform makes available a few very large data sets. Landsat, Sentinel-2, and the NexRad system, which is a US weather-based Doppler weather radar. And those are, you can imagine why these companies might want to make these available for free to their customers. The real challenges in terms of like dragging all these huge multi-terabyte, even petabyte data sets across a network. And so being able to locate the data in the same, from a network perspective, near the computational resources, it's a real advantage for people that might want to use it. So Google's done some really good work in this area, and Amazon actually runs a registry of open data that's stored on AWS. And they also have Sentinel and Landsat, and NexRad, but they have, this is just their Earth observation open data, pretty incredible array of data that they've assembled and make available to their customers. So even if you can't afford to have a satellite tasked for you, there's a lot of great data out there that is available for little or no charge, and that's a great place to get started. So I'm gonna stop, and got some time left to do some questions.
Thank you, Robert. Just a reminder, please post your questions in the Q&A box. We have a few questions now. Let me start with the one I have here on screen. Is I'm gonna condense it. So, question about the motivation of firms to share some of this data. The person asking the question refers to the OER data in the apparel supply chain. What incentives do firms have when sharing geospatial data, such as facility locations, addresses in their supply chain? And second part of the question, on the flip side of that, how does Acivia or other organizations promoting open source incentivize the private sector firms to share their geospatial data and contribute to open source projects?
Those are great questions, and I will do my best to respond without being disparaging to anyone. I think as I mentioned, some of this is, I think, driven by public pressure from customers and a certain amount of shame, being shamed into it. And I think that's a completely legitimate way to incentivize an organization to, or anyone to make change or do new things. In this particular case, that situation in Bangladesh from that building collapse really drove, might think of it as soul searching, but you might also think of it as embarrassment or shame around how workers are being treated. And I think these organizations, these brand companies that most of them are publicly traded brands that have millions of customers, and if those customers care about reputation, part of being a brand is that you have a reputation and you cultivate a positive reputation, so your consumers will want to buy from you. And if there is a public sense that they're failing to do so because of either negligence or not being willing to be more transparent about where their what's happening in their supply chain, there's the potential for exposure and damage to the brand reputation. That's one thing. The second thing that you highlight is that this data is often proprietary, or maybe seen as proprietary. Many of the brands have banded together in what they call multi-stakeholder initiatives, allied brands that share data amongst themselves in order to improve or monitor conditions. Many of them also send inspectors to locations, but they don't want their competitors to get hold of that data. So what we've tried to do on this particular project with our partners by the way, I should clarify, what began as the Open Apparel Registry as a technology project that was funded by the Loudest Foundation has been so successful that it is now turned into a separate nonprofit organization that now operates that. So as Avia, we're essentially the technology partner for this new nonprofit, also called the Open Apparel Registry. These MSIs want to have some assurance that proprietary and potentially proprietary information isn't going to be shared. So one of the things we've done is just make the Open Apparel Registry as simple as possible. We were under a fair amount of pressure to expand it out, to add factory inspections and environmental information and other kinds of input. And we deliberately scaled back the ambition to something very simple, simply location, which brand is using it, and trying to, and while it is geospatial, it's not explicitly geospatial, it's implicitly geospatial. So we need to add the map coordinates and then reconcile them across different databases. And that has generally been positively received. There's still people who are uncomfortable about it being shared with the general public. And so we've worked to navigate that in a way that's still meets our goals, but also is sensitive to those concerns. But it's largely been fairly successful. Now, how does someone? I think these are broader questions, though, that are not just specific to apparel, and I think that's what you're getting at with the second half of this. How do you incentivize private sector firms to share more data? I think a lot of it comes down to trade-offs between the proprietary data that they may feel like is competitively sensitive versus the trade-offs of making it available to the public. And it's a pretty broad array of there's a continuum of responses. I don't think expecting everyone to just become an open data organization is reasonable. There are real legitimate concerns there. But I do think that more companies have an opportunity to be more open than they generally have been, and I think there's some Open Apparel Registry, one example, but we're working with Facebook on some on a gender survey that they did internationally last year during COVID, and they have made a decision to try to make that available to the public, or companies that see Google and Google Maps as a competitive threat, and so they've banded together to, as an alternative to Google Maps, contribute to open data sets like the OpenStreetMap project, which Microsoft, Facebook, and a variety of other competitors to Google are contributing to as an alternative. So I think sometimes competition can be a way to make this happen, sometimes shame, and sometimes it'll depend on the situation.
Okay, thank you. Moving on to the next question. What is being done to protect space from thousands of satellites that are getting in the way of astronomical needs, such as long-term photography of stellar targets?
Yeah, I suspect this person's referring largely to the Starlink project. So I focused on Earth observation satellites, and I talked about things in terms of constellations of hundreds in low Earth orbit. some of the communication satellite constellations are measured in thousands. So Starlink is one that's being launched by SpaceX. And these aren't just thousands of them, but they also, I don't know if it's because of the antennas or the design, but can be highly reflective. And this is a real concern in the astronomical community that this is going to have a negative impact on the ability to observe stellar objects. I know that the Starlink folks have tried to respond by changing some of the design as well as shielding some of the reflectant surfaces in their more recent launches. I don't know, it's not, I think this is a real concern for people. I think there's also the prospect of satellites that become junk and destroy other satellites that are different orbital planes become polluted essentially with damaged instruments. And things are going to be pretty tough problems to manage in the coming years. Even a tiny satellite the size of a bread box, if it becomes dysfunctional and people lose control over it, can have cause enormous damage, could take out on its own much larger instruments. These are going to be important sort of infrastructure management questions we're going to have to deal with in the coming decades.
Awesome, thank you. Another question related to COVID-19 modeling. Has your company done any work on modeling the opioid crisis in the U.S., knowing that, here in Philadelphia we have, significant concern with that, and knowing that you're based in Philly and have these capabilities?
It's a great question. We have not done a lot of opioid mapping, but there are other people doing that kind of work. One company you might see if there are any case studies here. One of the large companies in our ecosystem is called Esri, ESRI, or Environmental Systems Research Institute. They're a fairly large commercial software developer. I doubt there's a lot of this that's going to be, for privacy reasons, that's going to be released as detailed data, but there may be sort of county level aggregation of information that could be useful. I do think this is something where people are mapping the opioid impacts of the opioid crisis, not just from a public health perspective, but also from the perspective of trying to hold people accountable through the legal system, and being able to show geospatially where opioid sales are versus abuse versus where marketing efforts by pharmaceutical companies have been. And I think there's some pretty interesting applications there.
Awesome. We have a couple more questions. So it's about the sensitivity of geospatial data. I think linking it back to the previous question, but is there a way for organizations to share data safely and securely, more so in terms of anonymizing the data, encrypting it, and keeping some sort of traceability in the data sets?
Yeah, this is a big, complex question, and really comes down to the ethics of data use. At the kind of medium resolution scale that we might have something like the Landsat instruments, 10 and 30 meters, there's not necessarily a lot of privacy concerns there. There's no way to see who you are walking down the street or read a license plate number or monitor, and there's only a revisit rate every 2 to 4 weeks. So it's less of a concern, but as the resolution of these systems goes up and the revisit rates rise, there's the ability to obviously use them for surveillance purposes, not just imagery, but I mentioned the Hawkeye 360 system that's being used for identifying illegal fishing, but you can imagine using that for all sorts of surveillance that really would potentially be violations of privacy. I think like other situations in which technology has outstripped our norms and regulatory regimes in terms of what can be done, we're going to face a period of time in which we're going to have to develop new norms and new regulations around how data is used. I think data practitioners, like a lot of the people on the call here, also have some responsibility to be thoughtful about how they gather data. I think there are real equity concerns around something that might seem as innocuous as labeling data for machine learning purposes. We've all seen that around facial recognition, and you might not expect that might be the case for something like satellite imagery. But imagine if you're trying to map disaster impact from hurricanes, and all of your training data is captured in the United States in suburban locations with a particular kind of settlement pattern with detached single-family homes surrounded by trees and other vegetation. Well, that's totally not going to be very helpful for mapping buildings or disaster impact or anything else in communities in which that settlement pattern isn't like that. So it means that if you're going to do something like mapping buildings, you need to capture your training data in a lot of different environments if you're going to be able to have the impact that you want to have. It was a pretty broad question. I'm not sure if I effectively answered it. Preventing bad actors from using open data is pretty tough. I mean, the whole idea of open data is it's openly available for people. I think the harder questions are how do we apply that data, and in what context is it? Are we doing so in a way that's fair and equitable?
Follow up on that question. I mean, just like location data, right? There's some, agreement on what type of resolution would be considered invasive. Is there a similar construct for geospatial?
Not for satellite imagery. There are some frameworks for I think thinking tools for talking through the ethics of trying to think about some of the efforts. The OMDR network has funded some work at GovLab around trying to develop some guidelines for ethical applications of geospatial data, but they necessarily end up being pretty general. I think these are going to be key privacy concerns. Under what circumstances is it appropriate to use data that might be quite helpful in one context, but might be a real violation of privacy in another context. I think our location information on our cell phones is one thing. Satellites and aerial drone imagery is going to be another. But this is going to be true for other types of things as well. For example, I think facial recognition has some, while we've heard in the news media about some of the potential violations of privacy it could be used for by police departments and whatnot, I can imagine it also being really useful for finding missing people, or have a relative that has dementia and wanders away, and we need to try and find them quickly before they injure themselves, or these sorts of circumstances. I think simply saying, all technology, all facial recognition technology should be banned is probably not going to be the right solution, but allowing police departments to use it in an unlimited way for surveillance is also utterly, I don't think, the kinds of norms or regulations that we would want to have. And so navigating this collectively as a society is going to be a real challenge in the coming years.
Awesome. One last question regarding the proliferation of smaller satellites and how that is, I guess, having or generating the issue of space debris, right?
Yeah, I referred to this earlier. These constellations, light pollution around astronomical objects of observation is one concern. Space debris is going to be another. And I think there's a lot of interesting technology being developed, whether it's to clean up debris or to more effectively track debris. as well as, I mean, tracking, as long as satellites have active propulsion systems, tracking debris enables them to move aside or move away from debris so there's not a collision. The worst cases are collisions or loss of control over satellites, and that one object then becomes thousands of small objects that are both harder to track and far more dangerous. It's going to be a real challenge, and it's not one limited to the small satellites that I was referring to here, but it happens when large objects control is lost and end up becoming thousands or tens of thousands of smaller ones. It's astonishing the degree to which NASA and the Defense Department and others are able to track these things, but it's a growing problem, and we're going to need, like the privacy questions, we're going to need new norms and regulations about what's allowed in order to
Next,
manage the sort of commons.
Sorry, excuse me. I'm going to squeeze in one last question.
Yeah, go for it.
It's about the latency of satellite data when it is streamed. Any challenges in that space? What are you seeing?
The latency
when streamed, I suppose the person is referring to real-time streaming of satellite data.
So most satellite imagery is not available in real time. So what you see in the movies, I mean, and maybe the CIA can do this, but a lot of these commercial companies can't. When an image is captured, it needs to be, it knows that we know where the satellite was, and we know where it was pointing when it was captured, but it may not have been rectified to the surface of the Earth. It may have been captured at an angle and needs to be ortho-rectified so that it has ground control points. Even amongst the same satellite generations, you're going to have different optical characteristics. So those need to be corrected for. The lens itself will be slightly different from device to device. And then you may get different, you're going to be looking down through different atmosphere. And so you need to be able to potentially correct for different atmospheric effects. So there's usually a fair amount of post-processing that happens. And when a new company gets going, they don't just launch satellites and start streaming the data down and like, here you go. And with kind of the casualness that we may think of doing so with our cameras on our smartphones, there's a fair amount of post-processing work, and a lot of effort goes into building a post-capture processing pipeline to get it from the capture point to the point where it's made available to the public. Even then, making it comparable between different systems, even if they are ostensibly capturing the same red, green, blue, or whatever portion of the spectrum they're capturing, it's not necessarily easy. So there's a long-term effort around what people call analysis-ready data, getting it to the point where it's not just ready for use, but ready to potentially be compared across different instruments. So people refer to this as ARD. It's a really big technical challenge, and some progress has been made, for example, in being able to mix Landsat and Sentinel instruments, but it's kind of a long-term effort. You also often can't mix and match machine learning training data sets. I may capture my machine learning data with a planet set of imagery, but I can't then apply that same training data very easily to some other instrument without some extra effort. The need to have different ground infrastructure. So the satellites need to transmit their data down, and you need antennas pointing up, capturing it, is creating new opportunities as well. So there's some interesting innovation around portable ground equipment. Companies like Amazon are not just making data processing infrastructure available. There's now an AWS, I think they call it ground segment or ground station, something like that. So they essentially will rent out ground stations. Yeah, it's called AWS Ground Station. It's a service where they rent out a fully managed ground station for accepting the imagery from a satellite, and they maintain a network around the globe for doing that. and they'll rent that out to some of these up and coming satellite companies that may not have the capital or want to build out their own infrastructure. And then finally, there is so much data being captured that some of the newest satellite designs are considering doing things like applying machine learning, like storing imagery on the satellite, applying machine learning to figure out what might be useful, and then only sending down the most useful images. So essentially pre-filtering on instrument. So another iteration of edge computing in order to reduce the amount of imagery that needs to be sent down.
Wow, awesome, amazing. Well, thank you, Robert. This is really an exciting topic and one full of opportunities for the operations research and analytics community. Thanks everyone for joining today. And I just want to share with all of you that we're going to be holding a membership meeting on the 13th, July 13th at 6 p.m. We'll send some of the information to join the meeting, and the purpose is to get to know the local chapter, share ideas, get involved in some of the planning activities. You know, we do the speaker series, but we also do the networking event. And we obviously pre-COVID, you know, we would select a corporate sponsor, and you know, I think it's been fun in prior years, seeing, you know, what can we do this year, and thinking about, you know, what do we keep with a virtual format like this one, and what can we do in person. So your feedback will be very valuable, and you can send us you know, your thoughts to the philadelphia.informs@gmail.com address, or get in touch with any of us um, as we send out some additional notifications about this activity. So with that, thank you very much for joining. Robert, again, thank you. Really awesome topic, and I'm sure it sparked a lot of interest in the field, which is not you know, within our typical training, right, as analysts and operations researchers. So, but actually one that will probably play a big role in the future. So thanks again.